All right. So what we're going to do, so here we have a graph, and sorry, I just copied this from an older note. I just kind of drew and colored on it just for fun. But here we are given a trig function, and we want to find the equation of the graph. But the equation we want to come up with is going to be a sine equation. So if you remember yesterday, I was saying for sine or cosine for our trig waves, however you want to call them, for every wave, I can either come up with an equation that follows sine, or I can come up with an equation for the same graph, but with a cosine. All right. So what you kind of have to do is say, okay, well, what part do I want to use? So like, if I look like I'm going to highlight just one, right? So like, if I look like if I start here and go up, down, and then back up again, right? Like this is one cycle for sine, okay? So like, I'm just going to decide, I'm going to come up with an equation for this one, okay? So again, what we need to do is we need to figure out our axis of the curve, right? So again, the axis of the curve is the horizontal line that kind of cuts the function in half. So if I'm using sine, like the starting point of sine is generally where the axis of the curve is, all right? So here, right, I have y equals -1, right? So that means my axis, sorry, I don't like that. I want a kind of sleeker looking pen. Right, we have the axis of the curve, right, is y equals -1. Okay, cool. Amplitude, remember, is like this distance, right? From the axis of the curve to the max, and then from the axis of the curve to the min. And again, the amplitude is going to be the same whether I go from the axis of the curve to the max or the axis of the curve to the min. So that we can just count on the graph, right? From here to here. So every square is 1, so it's 1, 2, 3, 4. And then this one, if we can check, right, 1, 2, 3, 4. Right, so my amplitude is 4, my amplitude is 4. So my A value is 4. Okay, cool. Now, we need to figure out the period of the function, okay? Now remember, for the period, I use this formula here, like to figure out the period, if I knew what k was in the equation, because yesterday we were given a bunch of equations, and then I could have to find the period. Here, I don't have to use this because literally from the graph we can count, right? If I say, well, what's the horizontal distance from? Oh, why is this not working? Right, from here to here, right? Well, if I look, right, this is going, so it's going from 60 to 180, right? That's the distance, the horizontal distance, all right? So let me just write that. We don't need to use this formula in these questions. Here I can just count it, right? And again, if you don't know how to, you can just, every square is 30, or you can go 180 minus 60, whatever you want, right? They're like 3, 4, or 3, 6, 8, so it's 90, right? Well, sorry, not that. What am I saying? Period is going to be 180 minus 60, right, which is 120. All right. So again, so I have the period. So again, for me to find the period, I don't need to use that formula, okay? But what I need to use now is I'm going to use the formula to get the K value, okay? So let's put a little star here. And again, how did that work? Well, if I write 120, and then now what I want to do is I want to solve for K. So again, if I cross multiply, I'm going to get K equals 360 over 120. So K equals 3. All right. So now remember what that means, right? The K was the horizontal stretch or compression. So obviously, when we think about this and we compare it to the regular sine function or cosine, right? What's the period of sine or cosine? With the regular one, it's 360. The period is 120. So obviously it makes sense that the graph of sine of x has been compressed, has been squished. So it makes sense for the K value to be 3. Okay. So I have the A value, I have the axis of the curve, I know my period, so then I got the K value. And then the last thing we need to do is just figure out the phase shift. And if I look here, well, what's my phase shift? Well, remember, sine generally, the regular sine starts here. And all I've done is I've shifted it. How many? That looks like about 60 degrees this way, right? So it's going to be 60 degrees to the right. All right. So now I have all the information that I need to come up with the equation. Okay. So again, I have my A value is 4. Okay. What? Sure. K value is 3. I'm moving 60 degrees to the right. And then remember, my axis of the curve is -1. So that means we're going down 1. Okay. So when I write my equation out, so we're going to have it's going to be 4 and then sine. And then K is 3. Oops, screw that one up, sorry. K is 3. And then bracket X. Now again, if we're moving 60 to the right, then it's going to be the opposite sign, right? And then the axis of the curve was y equals -1, so we're going to go -1. All right, so that is the equation of that graph using the sine function. All right. So let's try another one, and we'll see how it goes. All right. Okay, so here, again, I have a nice little wave, and the only difference is what we're going to do is we're going to come up with an equation with sine, and then we're going to come up with an equation for cos. Okay, so again, we're going to have two different equations for the graph, one with sine, one with cosine, but they make the same graph. Okay, so again, here, what I can draw, right, now notice how this is shifted. This is shifted in a different kind of way. So like, hopefully by now when you look at these, and if we look at sine first, like I can visualize, I can see the axis of the curve and where it's going to be, right? So I want to cut my trig function this way. And then clearly, if you look at the graph, you know that's y equals 3, right? So y equals 3 is my axis of the curve. Okay, amplitude, again, right? It's this amount here and this amount there. And no crazy calculation needed because you can just count on the graph. This goes from 3 to 5. This goes from 3 to 1, right? So here the amplitude is 2, okay? So my amplitude, which is just my A value, equals 2. And then y equals 3 is the axis of the curve. All right. Now, if you look at the period of the function, again, it doesn't matter which, like I'm starting up with sine because I see sine right away and whatever. It seems like the easier one to deal with. I want to look, what's the distance from here to here before it repeats? Well, that's 30, that's 120. So the period is going to be 120 minus 30, right, which is 90. So that means that what we're going to do, right, to find the k value, right, the period equals 360 over k. I can literally just rearrange it and say, well, to find k, I just go 360 divided by the period. So 360 over 90. So k equals 4. And again, that makes sense, right? Remember when the k value was bigger than 1, that was a horizontal compression. And clearly, if one wave is 90, that's a shorter wave than one that was 360. All right. So I got the amplitude, we got the axis of the curve. I figured the periods, then I know the k value that goes in there. And then last thing is the shift. And again, if I look, right, generally sine starts here. So I've shifted 30 to the right, right? Right. So 30 to the right. So that means if we want to answer part A, we can go right into it. So y equals, all right, so my amplitude is 2. So 2 sine. And then the k value is 4. All right, and then we're going to put a bracket. And then x, and the shift is 30 to the right. So minus 30. And then the last thing is the axis of the curve, which is plus 3. All right. So there is our beautiful equation. All right. And then now what we're going to do is we're just going to do the same process, but come up with a sine one, or sorry, cosine. Now you may remember, you may not. Yesterday I said that you may think that, oh man, it's so much work. I got to come up with 2 equations for one function, like that's double the work. Well, really it's not, because remember, like if I look at this wave, like the amplitude is consistent throughout the whole wave. So the amplitude is not going to change. The axis of the curve will never change. So that part in the equation will never change. The period will never change. So that means the k value, guess what, won't change. So the only thing we need to determine is the shift, okay? So let's figure that out. Okay, so I'll do part B down here. And I'll just write that down. So everything else is pretty much the same. except the phase shift. I guess there's one other thing that can change, and that's like you could have it reflected over the x-axis, but that doesn't change. That just changes like whether the graph goes like this or like that. I'm sure you understood everything with my hand gestures, but that still doesn't change the amplitude at all. So first things first, well, okay, we need to establish like a cosine, like what, graph. So what we can do if I look, so okay, I'm gonna do this one here. So let's pick color. Okay, so I'm gonna start here. And okay, so that is my cosine graph, right? And just one thing to notice, okay? So like remember the 5 key points we always talked about? So again, I'm gonna have a point, like, so cosine has the 2 points at the maximum, a point at the min, and then 2 key points on the axis of the curve. All right. So now when you look here, if I go down, right, you'd be looking like, like I'm not like 100% sure like what this value is, right? And so like you may be kind of like thinking, well, like, how do we figure out what's it called? Like the proper shift, right? Because we know when I look at this, right? I know I've shifted it this way, right? But like, what is that shift? Okay. So, I mean, if you think about it, well, if we look at, for example, the sine graph we have here, right? So let me just, well, actually, let me write something else down. I'm just going to write it on the graph below just because I feel like it. Right, so the period is 100 and, oh, sorry, not 120. Sorry, the period is 90, correct? So if you remember when we came up for or yesterday's questions, you had to determine the scale for the key points. You would take the period divided into four equal chunks, right? So here we could figure out the scale is just going to be 90 divided by 4, right? And if you do that, what's 90 divided by 4? That's going to be, so if I divide it by 2, right, 45 divided by 2. So if I do long division, oh, this is amazing, 2 and 4, 0, 5, right? 2, sorry. Oh, this is embarrassing. 22.5, right? I think it's 22.5. And again, that makes sense because if you go 22.5 times 4, you'll get 90. So that means, if you can forgive my embarrassment there, trying to do long division when the answers popped in my head. It means that every mark, so like the gap from here to here, like this distance is 22.5, right? And then this distance is 22.5. Okay. So now why is that helpful? Well, now I know because I know that each key point, the distance horizontally is 22.5, then I can literally calculate the proper shift. So I'm going to erase this just for our sanity, right? Let's get another color. Okay, so again, what is this point? This point down here is 30. Now, what is this point? Okay, well, so I know that this point down here right, is going to be 30, I'll write it down here, plus 22.5. Because like I said, the horizontal gap between every key point is 22.5 degrees. So that is 52.5 degrees, right? So that's what this is. Okay, and again, this is where my cosine starts, the one that that we're going to come up with the equation. Okay. Right, so that's 52.5 degrees. So my shift is that amount, 52.5. Okay. So again, this is one where like notice we start with sine because sine gives me I can look at the graph immediately and determine that, okay, I know what the shift is. Whereas for cosine, you just have to look at the scale, see the gap between each key point, and then it's, not that hard. Okay, so again, now is the cosine upside down? No, it's right side up, it's fine. So that means that this graph here, the a value isn't gonna be negative. So what do we got? Okay, so let's do it. So y equals, so remember, everything else is gonna be the same as the graph up here, just the only thing that's gonna change is the shift. So we're gonna have 2 cos, and then 4, right? And then x minus 52.5. And then what was the shift? I think plus 3, right? Plus 3. All right. So that is our other equation. Okay. Now, the beauty about all this is that, like let's just check. I mean, I feel pretty confident, but just so that you don't believe me and you can believe the graph, like if we go to Desmos right now, just for fun. And we go to graphing calculator. And I'm just going to type these 2 equations, and hopefully they actually give me only one graph. So again, when we're doing all this stuff in trigonometry, we need to change it to degrees. All right. And remember, we want to change the window. Okay. So I'm going to change the window. So remember, now our domain is really big because trig functions can have a period of 360 or 90 or whatever. So I'm going to leave it. Let's do 0, or let's do minus 45. And let's just pick 360, whatever. Okay. And then the y window, if I remember correctly, let's see, what does it look like? So it's, so -1 and 5. So I'll go 0 and 6. Right. So 0 and 6. Okay. Actually, let me just go down like -2, just so it looks a little nice. Okay. And so now we have that. Oh, hold on. I like reverse contrast. Cool. So now if we type in, so what was it? It was 2 sine 4x minus 30 plus 3. Why? Oh, there we go. Okay. Right, was that it? I think so, right? Let me just double check. 2 sine 4x minus, yeah, okay. All right, so just notice how I put in Desmos, I don't need to put the double bracket around there. Oh, you know what? I think if I do this is right. Let's see. Oh yeah, Desmos, just because the square brackets are something else. All right, so there's my graph. Cool. All right. Now, if we type in the cosine equation, then we should only see, like, this graph won't change. So it was 2 cos 4 and then x minus 52.5. plus 3. And it's like, oh, sick. Look at that. Right? So graph is hiding. Graph. So we were correct. Cool. All right. So what we'll do, let's just take a short little break just for our sanity. And we'll come back and we'll look at the application questions. Okay?